So here with I want to share my views on edge computing intelligence to COVID-19 as a top and what is associated also from Department of Voting PhD College of Technology. So I want to share few things. In this pandemic human crisis, what are the issues involved with that and what is the need of the her, why edge computing is required, the characteristics, different kinds of applications to focus on. So with this pandemic human crisis involved, let me start with the word called as telecommute, the buzzword. So telecommute here in the sense commute it tells it is travel, whereas telecommute in the sense we are not going to commute or travel. Instead, whatever be the work intended to do, we are going to communicate or connected with people to be connected with, share the work, everything in a digitized way. That way I call it as telecommute. Either it is an official work or school works or entertainments, everything we are doing without traveling. That I call it as telecommute. And the problems involved with it is one is Netflix. Lot amount of movies are downloading this Netflix, so the streaming resolution is very high, and the people, the vendor has to get compromise or negotiate such that they could not able to provide highest streaming resolution as most of the people are downloading the things. And recently they announced this high streaming is not possible in the European countries. Second problem considered is PUBG marathons. Most of the houses, the adults or youngsters, they used to play these games PUBG where the parent population is very high. It is an unimaginable one current days. And then third one is video conferencing applications. If you consider Zoom or Cisco WebEx or Gmail, there is an unprecedented amount of downloads. Where these downloads, we are not unexperienced with. So to the put in a nutshell, the current networks were never designed to handle this kind of traffic. So the case study one, what I've considered is you assume an app that has been designed to handle only with 100,000 requests, and suppose if it is has been to handle 200,000 requests, suddenly it has been scaled up. So what could be the thing that has been faced by the providers? So the lot amount of overburdening the server will happen, and large amount of spectrum has been consumed, and ultimately results in lot of delays or partial outages. Case study 2, what I will consider, the reference is given below, the cyber attacks. The number of cyber attacks has been increased recently due to this pandemic. In March, it has been doubled. In April, it has been tripled. A lot of people, the attackers, they try to infiltrate the networks. They try to gain the information, doing some disruptions or unwanted misuses with the network. In the case study 3, what I consider is video conferencing. Zoom has been a sharp rise in the few days, where 6 lakh downloads have happened in per day. It was initially designed as enterprise technology tool, not as a social tool, but now it has been transformed as a social tool. So this moderate use case behavior, what is the intended to do? Since they have not expected this much amount of downloads, lot of abuses or misuses has been happened, and few news channels they've telecasted that lot of reports and complaints has been filed where the reference is given. So with these case studies, with the issues, what we have found is partial outages, delay, less security, low quality, streaming quality, latency, scalability is a problem, volume and bandwidth is a problem. So we want to resolve all these issues using the existing computing paradigms. This is a proper solution. Let me consider. So if we talk with the cluster computing, it is a homogeneous collection of nodes, and one primary node will be act as a gateway. Since it is a homogeneous collection, that could not be the better choice. Moving towards the grid, it is a cluster of clusters, and it is heterogeneous, well distributed. It works in the WAN environment, but it is a domain specific one. So later we move towards the utility computing. So whatever I am going to use, I am going to pay for it, and that was the route for cloud computing. So if you want me consider this as the promising solution for these issues to get resolved. So the different kind of machines are being connected and to the cloud server, major server. So where a lot of analytics and processing is done, and proper storage will be done with this cloud computing. But consider one application where you are using the drones, as we are seen in the few of the, even in the villages, they are using the drones to check whether people are resting inside the home. So in this case, you assume drone is placed in the region 1 and this server has been placed in the region 3. And if I want to control the zone, to gather some information from the zone, do some analytics with the zone, if you want to give an instantaneous request to this drone, if you want to reach the drone immediately, it is not possible since the server resides in the region 3, whereas the drone is present in region 1. So the communication gap, communication bandwidth, it will be very high, latency is will be very high, throughput is very high. So in this case, the promising solution which I considered is edge computing, and most of the governments consider this edge computing as a crucial weapon in the current day to fight against this COVID. It is a widespread adoption takes place to be proved as a promising and a permanent solution hereafter from these days on. And you may ask why and how. So here you just have a glimpse upon this image given. So initially it was two-layered architecture. Whatever devices I have, everything will be connected to the cloud through internet. And here I want to insert a layer between these devices and cloud, an intermediate layer, which I call it as the edge layer, edge computing servers. So here all these devices are well connected to the edge server. Finally, it in turn connects to the cloud. So if you want to gain the information from the drone to the region one, then if I place this edge server, it will collect the data, process the data, and whatever be the intended data to be sent to the cloud, those data alone will be sent to the cloud. So it is a three-layered architecture. And this allows local computing. So here nowadays the data is growing exponentially rather than the service. So here, not like olden days, the data has to be sent to the server. The server must reside very close to the data. That is assumed to be the holistic framework. So now you are pushing the server very close to the data, collect the data, and do all kind of analytics, wrap the data with proper security mechanism, and send back it to cloud. So that whatever issues I have discussed, all these issues will get resolved. Outages will not be a problem, delay will not be a problem, even high bandwidth, high quality streaming data can be sent, proper security can be adopted. So the communication path in this edge computing network is things in the sense your all kind of devices will be send the data to the local network, which I call it as edge network. Through net connection, whatever data is supposed to send back to the cloud, I'll send it to the backend services. And here with industry 4.0, earlier it was industry 1.0, where the mechanization process gets improved in 18th century. And in industry 2.0, all the automobiles have been stepped to the next level. And industry 3.0, computers let into the role of this mechanical industry for some automation purpose. And for industry 4.0, you can look upon few applications listed. And here the robust bandwidth, lot of analytics, lot of processing, everything can be happen, directly collect the data, work it there itself, and whatever be the intended result to be sent back will be sent back. So this is the recent statistics days. Every day we are getting 2.5 quintillion bytes of data. Quintillion is 10 power 18, 1 followed by 18 zeros. You assume the humongous collection of data, and this amount of data has to be handled, processed well, safely, and sent back. And this data will not be going to reduce for whatever be the reason. Every year it is going to get increased, as like Moore's law, it is going to develop, it is going to, there will be exponential growth of data. So to handle these data in a proper manner, a different kind of environment or layered architecture is required, that we call it as edge architecture. So here it is a three-layered architecture, placing an edge server between cloud and sources of data. I mean, the edge and fog computing resembles like same, but it is not actually so. So this edge computing, whenever I say this edge server is placed very close to this data to collect the data directly from the sensors, actuators, and controllers, and from where it does the process and sent back to the cloud. If it is a fog, it is a layered architecture placed above edge. It is like a device fixed or fitted upon in the LAN network. Upon collecting the data from the edge, it do a few kind of fine-grained analytics and send back to the cloud. So the basic characteristics of edge computing are: it is geographically distributed, scalability is possible, it is completely autonomous, heterogeneous, low latency, real-time interactions is possible, and the kinds of data it deals with is very time sensitive or less time sensitive. Less time sensitive in the sense it does not require the results immediately. So we call it as less time sensitive. It can be held back in the edge server. And if you want the result immediately to get processed and few to be sent back to the cloud server, I call it as very time sensitive data. And this is a layered architecture, three-layered architecture. And the benefits are: it is faster response, cost effective, reliable, and secure. And few applications I've discussed with this pandemic involved. So the drone technology and deployment. So the drones has been played a major vital role in different countries and cities, even in the Panchayat unions. To disinfect cities, in China they make use of drones. To enforce the lockdown measurements, whether the people are staying inside the home, in India and Spain, they have made use of drones. To check medical supplies, aerial surveys, and to deliver the groceries, they have made use of drones. And you may ask why edge computing is required. So if you, as I said, between region 1 and 3, if the proper control has to be take place, proper execution, proper containment has to be in the place, then you can make use of edge computing, where you can directly control this device. If suppose this device is gathering the pictures and sent back to the edge server, a lot more analytics can be done over there itself, and it can be shared across the world. And the second one, what I consider is self-driving car, autonomous car. So we could not able to completely dependent upon this machine, self-driving car. lot more things has to be done before it has been let into the market. So if edge server is placed very close in the proximity of this server, so it do a lot of decision making. If something went wrong, some glitches or error occurs, directly denotes it to the self-driving car, so that lot of accidents or mishaps can be avoided. And the other possible applications which can be considered are gaming and IT sectors. And edge analytics is a promising application where a lot of analytics we can do, and a few use cases I have shared with. And these are all the companies they are working with this edge analytics: Dell, IBM, Intel, Cisco, and HP, and few use cases. And if you want to do some fog analytics, few resources also I have shared with. URLs are provided with. And the other application which is considered as data security, if you want to properly send back the data to the server, properly it has to be wrapped with. So the classical encryption scheme alone is not suffice. So we can move it with attribute-based proxy decryption, homomorphic encryption, functional, and honey encryption. And these are all the platforms or devices which is available in the market to set up this edge server. Dell machines, HPE's gateways, and HP IBM Watson Analytics. Specs is provided here. And the limitations with this is the flaws, deployment, monitoring, and managing is a nightmare, where it is considered, still it is considered to be a complex one. The other challenges and security issues considered are achieving confidentiality and integrity, and the power consumption, as it is not a single node, multiple nodes are involved. Power consumption is very high than centralized machine. And the data security here, as the data generates from different nodes, how to properly distributed, authentication and operation systems to be incorporated, it's a difficult task. And the fault tolerance, it should not go fault tolerant, so how it has to be immediately fixed, as it is the multiple span of servers. And the programming architecture, what has to be entailed across the machines, is considered as the security issues. And these are all the related organizations that are working towards the cloud. And hereafter, they're no longer business to be as usual. So the life-saving applications of network devices we are testing so many years, gain reputable validation. So whatever be the applications like manufacturing, retail, or healthcare sectors, we have to regulate and reduce the human interaction hereafter. So to the current pandemic, it is simply accelerating the inevitable. It is necessary the fourth industrial revolution. So this revolution hereafter will be powered at the edge computing.